Hi, this is Sonia Doucette. In this video, I'm going to show you how to find the concentration in molarity of a solution for two cases. One case where you're given moles of solute and a volume of solution, and another case where you're given grams of solute and a volume of solution. So the first case is the easier case. So this problem says that there are 0.805 moles of sodium dihydrogen phosphate in 1.75 liters of solution. What is the molarity of this solution? So you start with what you know, and well, let's start with the definition of molarity first. So molarity is equal to the moles of solute over the liters of total solution. So the solution is going to be the solute plus the solvent together. How many liters of those two together are there? And then the numerator is just the moles of solute. So your solute in this case is the Na2HPO4, and you know how many moles there are, so you can put that in your numerator. You have 0.805 moles of sodium hydrogen phosphate. Sorry, I think I called that dihydrogen phosphate before. It's just hydrogen phosphate. Okay, and then you want to put that over liters of solution. So you're also given how many liters of solution you have. You have 1.75 liters of solution. So if you do the math there, you get for your molarity or your concentration as 0.460 liters of Na2HPO4. So that's your answer. That is the that is the molarity, not liters. That is the molarity of your solution. So moles per liter. That's your concentration. There are other ways to report concentration other than molarity, but they won't be covered at this time. Okay, so part B says 6.20 grams of potassium iodide are dissolved in 800 milliliters of water. What is the concentration in molarity of the solution? So in this case, you're given the solute in a mass instead of moles. So you have to take one additional step here, and that step is to calculate grams, calculate moles from grams. So you know that you have 6.20 grams of potassium iodide, and you can convert that to moles of potassium iodide using the molar mass, which is 166 grams of potassium iodide per 1 mole of potassium iodide. So that's going to give you 0.03739 moles. It goes on in your calculator, but I'm going to leave things expanded here because we have to do one more calculation before we get to molarity, and that is to divide by the volume. So you know that the definition of molarity is moles per liter, so we're looking for things in molarity. This big M is the abbreviation for molarity, capital M. So you want moles of potassium iodide, which is your solute, per liters of solution. So the volume that you're given is in milliliters. So you need to convert that to liters. So in the denominator here, we could put 800 milliliters, and there are 1,000 milliliters in 1 liter. And then if you do all the math there, you'll end up with 0.0467 for your molarity of potassium iodide. So that's your answer.